Advanced 2021 paper 2 paragraph for definite integration. This problem was from definite integration. So what do we have here? We have four functions. Phi1 is close 0 to infinity to all real number. Phi2 also close 0 to infinity to all real number. Basically all four functions has same domain and codomain. F of 0, g of 0 is given and all four functions are given. So we have two problems and each of them has four parts. They're asking which of them are true. So we'll discuss all eight parts here one by one. We'll get the answer by solving few of the parts also, but let us discuss all these parts for your concept clarity. So let us start. G of x is given as 0 to x square square root of t e power minus t dt. I'll put t as u square here, dt will be 2u du. So g of x will come out to be 0 to x 2u square e power minus u square du, and then we can convert u into t also, just write u as t. So 0 to x 2t square e power minus t square dt. Next, f of x is 0 to x t minus t square e power minus t square dt. Actually, in the question it is given as minus x to x, but the function is even, so we can write as 2 times 0 to x. And mod t also in this interval will be just t, because t is positive here. Now, if you add 1 and 2, we get 0 to x 2t e power minus t square dt, which you can directly integrate, just multiply divide by minus 1. And this integration will directly be e power minus t square. This minus 1 will be here. Limits are 0 to x. When you put the value of limits, you get 1 minus e power minus x square. Now, in one of the parts, they're asking the value of this thing at x equal to square root of ln 3. So when you put x as square root of ln 3, this will become e power minus ln 3, 1 minus that. E power minus ln 3 will be 1 by 3, so you get 1 minus 1 by 3, which will be 2 by 3. In this, they're asking if this is equal to 1 by 3, so we can say it will not be equal to 1 by 3. That is false. Next. In one of the parts, they're asking about the increasing. In what interval fx is increasing? So we'll find f dash x. This part is there. We can differentiate using the Newton-Leibniz rule. 2x minus x square into e power minus x square. You get 2x into 1 minus x e power minus x square. You know this e power minus x square will always be positive. So for this thing, just use the wavy curve. We get 0 and 1 are the roots. It's 1 minus x. So I'll change the signs here. It will be minus, plus, minus. Between 0 and 1, it will be increasing. In that part, they are saying it is increasing in 0 to 3 by 2. This will also be false. Going ahead. Now, in one of the parts, they're asking to compare f of x with this series. What do we do here? F of x as they have given is 0 to x 2t e power minus t square dt minus 2 0 to x t square e power minus t square dt. This already we have integrated here. Get 1 minus e power minus x square. To integrate this thing, I'll use the expansion of e power x, which is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Now, when you integrate here, you get something like this. 1 minus e power minus x square minus 2x cube by 3 plus 2x power 5 by 5 minus x power 7 by 7 and so on. Now, x belong to 0 to 1 by 2. We have to compare fx with this series. If you see this series, like these terms are same, exactly same. After that, we have minus of something, and x is 0 to 1 by 2, but it's a positive number. So whenever you have like an infinite series and you stop somewhere, and after that you have minus of something, we can say fx will be less than this thing, because fx is this minus something. So this thing fx is greater than equal to that. So this will be false, because fx will be this minus something. See, next term will be positive also, but this will be more dominating term right now. So this will decide the sign. So if it is minus of this, That means fx will be less than this. So this is false. Now gx, in gx you will see like gx is this thing only. There will be no negative here. So I'll just use the same series again. We get gx as 2x cubed by 3 minus 2x power 5 by 5 plus x power 7 by 7. And add the next term also, which will be 2 by 3 factorial x power 9 by 9. Now, saying gx we have to compare with this series only. Again, you see this minus something, so gx will be less than that, which is what they are saying here. So this option will be true. Next one. Now we talk about f1x and f2x. So f1x is given as f1x is given as e power minus x plus x, and domain is x greater than equal to 0. Now we have, one second to check, greater than equal to 0, correct? Now in one of the part they're asking if f1x is less than equal to 1 or not. So if I differentiate here, you get 1 minus e power minus x. For x greater than 0, it will always be positive. That means f1x will be increasing function. Value at 0 is 1. So that means f1x will be always greater than equal to 1. So this will be false. Next, this saying for every x greater than 1, there exists an alpha from 1 to x such that phi 1x is equal to 1 plus alpha x. Just equate phi 1x equal to 1 plus alpha x, you get e power x minus x equal to 1 plus alpha minus 1x. Now e power minus x graph will be like this decreasing graph. Value at 0 will be 1. 1 plus alpha minus 1x. See, alpha is also a changing value, but what we can say is alpha is more than 1. So if alpha is more than 1, this will be a line with positive slope. Value at 0 will be 1. Now, for x greater than 1, there can never be a solution. So it will be false. Next, for phi 2x, we have to check this thing first. Phi 2x less than equal to 0 for all x greater than 0. So phi 2x is x square minus 2x plus 2 minus 2 e power minus x for x greater than equal to 0. Differentiate here, you get 2 times x plus e power minus x minus 2. If you see, this thing is nothing but phi 1x. So get 2 times phi 1x minus 1. We already discussed phi 1x is already greater than equal to 1, so this thing will always be positive. That means phi 2x is increasing function. Value of phi 2 0 is 0. That means phi 2x will always be greater than equal to 0. This will also be false. Next, they are saying for every x greater than 0, there exists a beta of 0 to x such that phi 2x is equal to 2x, phi 1 beta minus 1. These kind of problems are usually based upon LMVT, Lagrange mean value theorem. So just this thing beta 0 to x, so we use LMVT from 0 x to 0, 0 to x. So phi 2x minus phi 2 0 by x minus 0 will be phi 2 dash beta, where beta belongs to 0 to x. And phi 2 0 is 0, this x go this side, and phi 2 dash beta, we discuss here phi 2 dash x was 2 times phi 1 x minus 1. So 2 times phi 1 beta minus 1 into x here, that means phi 2x is equal to 2x phi 1 beta minus 1. So this will be true.